morning friends. Last we discussed about the momentum transferred by the gas molecule to the wall of a container in delta T time is nma Vx square into delta T. That is the momentum gained by the wall of a container in delta T time due to the n molecules, that means the small n, number of molecule per unit volume. This molecule transfer the momentum to the wall of a container in delta T time. Now we are interested to obtain the equation of pressure. How much pressure act on the wall of a container due to the molecule of the gas. For that purpose, the question is asked like to that way: accept the equation of momentum imparted on the wall of a container and obtain the equation of pressure act on a wall. Or this equation is also asked like to that way: accept the changing momentum of the wall delta P is equal to nma Vx square into delta T and obtain equation of pressure. So here we are using the Newton's second law of motion. Therefore the force is equal to changing momentum upon time interval. So first we are finding the F. F is equal to delta P upon delta T. After finding the force acting on a wall, pressure P is equal to force per unit area. Force per unit area. So this way we can obtain the equation of pressure. For that purpose, here we have to accept the equation of momentum. Right? Therefore, the momentum transferred by gas molecule to the wall, to a wall in delta T time is delta P is equal to nma Vx square delta T. Now what is the n? N is the number of molecules per unit volume. M is mass of a molecule. A is the area of the wall. Vx square, that is the square of velocity of a particle in the direction of x-axis, or that is the x square of x component of velocity of a molecule, and delta T is the time interval. Now force acting on a wall, act on a wall is due to this change in momentum, how much force imparted on a wall. F is equal to delta P upon delta T from Newton's second law of motion. So delta P already given, nma Vx square delta T upon delta T. So delta T cancel, therefore nma Vx square. So that is the equation of the force acting on a wall. Now pressure P is equal to F upon A, force per unit area. That much force acting on entire wall of a container in delta T time. Therefore, force F upon A, that is the pressure. Therefore, pressure is equal to nma Vx square upon A. A cancel, therefore nm Vx square. nm Vx square. Now listen, here there is the pressure act on a wall due to the molecule of a gas are collide with a wall. So here what are the molecules are collide with a wall? All molecules do not have the same velocity, and due to that result, in this equation, that is our equation number 2. Equation 1 is this momentum. So in this equation, there is the pressure act on a wall due to the molecule of a gas. All molecules do not have the same velocity. Therefore, in this equation, we take the average value of the velocity. So instead of the Vx square, average Vx square. Right? Now, all molecules do not have same velocity. Or in other words, all molecules are not moving with the same speed or the same velocity. Therefore, taking average value of Vx square in equation 2. Therefore, P is equal to Nm average Vx square. That is our equation number 3. But in postulate, we also discuss about that the number of the molecules in a container are very large, and also they perform the random motion. Random motion, that means the direction of the motion of the molecule are not fixed. All the molecules are moving randomly, and therefore in Cartesian coordinate system we consider that only the three directions x, y and z. Therefore some molecules are moving along the x direction, some along the y, some along the z. And the average velocity in all directions are same. All directions are same. Right? Therefore, due to the random motion of the molecule, the average value of the velocity in all directions are same. Therefore, in x direction, the component of the velocity is Vx. Along the y direction, component of the velocity is Vy. And along the z direction, the component of velocity Vz has the same square average value. Now, molecules perform random motion or the moving with random, and their velocity in all directions are same. So that average Vx square is equal to average Vy square is equal to average Vz square. And already we discussed in chapter 3 motion in a straight line. The component of the velocity of V are Vx, Vy, Vz. V are the component of velocity Vx, Vy, Vz. Therefore, the V square is equal to Vx square plus Vy square plus Vz square. Or in other words, the magnitude of the velocity is equal to the square root of sum of square of its component. Therefore, the average value of the V square is equal to Vx square plus Vy square plus Vz square. We are using this concept here. Average V square is equal to Vx square plus Vy square plus Vz square. There is a equation 4 and equation 5. But in equation 4, the square speed of the particle in all directions are equal. Therefore, instead of the Vy square and Vz square, we can add the Vx. Therefore, 3 times average Vx square. Therefore, the value of average Vx square is equal to 1/3 V square. That is equation number 6. Substitute the value of Vx square in equation 3. substitute in equation 3. Therefore, the pressure is equal to Nm into 1/3 average V square. That is your equation number 7. But Nm is equal to density. Is equal to density of a gas. How N into M represents the density? M is the mass. N is equal to number of molecules per unit volume. Therefore, Nm is equal to Nm upon V. Now, this term represents the total mass. And that is the volume. Therefore, mass upon volume, that gives the density. That is the density of a gas. For information, we can add this here. Now listen here. N into M is equal to N upon V, number of molecule per unit volume, into M, is equal to total mass upon volume. That gives the density. That gives the density. Therefore, P is equal to 1/3 rho average V square. That is the equation of pressure act on a wall due to the collision of molecule of a gas. Equation A shows the pressure act on a wall due to collision of molecules of gas. So P is equal to 1/3 rho average V square. So very easy equation. So frequently this question is asked for 2 marks question. Accept the equation of the momentum imparted in a wall and obtain the equation of pressure act on a wall. Or in other words, accept the change in momentum of the wall delta P is equal to NMA Vx square into delta T and obtain the equation of the pressure 1/3 rho average square. So first we accept this equation. Therefore, the momentum transferred by gas molecule to a wall in delta T time is delta P is equal to NMA Vx square into delta T. That is equation number 1. Now, from Newton's second law of motion, the change in momentum, time rate of change in momentum of a particle is the force acting on it. Therefore, force act on a wall is F is equal to delta P by delta T. Delta P NMA Vx square into delta T upon delta T. Delta T cancel, we obtain NMA Vx square. Okay. Now, the pressure, after finding the force per unit area, that gives the pressure, because we are interested to obtain the equation of pressure. Therefore, pressure P is equal to F upon A. Now, P is equal to F. F is equal to NMA Vx square. Divided by A cancel, therefore NM Vx square. Here the Vx square is the square of velocity of a molecule in x direction. Okay. Now, what are the molecules traveling along the x direction do not have the same velocity? Therefore, we are taking the square value of this velocity as an average value. For all molecules do not have the same velocity, taking the average value of Vx square in this equation. Therefore, P is equal to Nm average Vx square. That is our equation number 3. Now, molecule perform the random motion, and their velocity in all directions are same, so that along the x direction, average velocity is vx square is equal to the same value of average velocity along y direction and also in z direction. So it is equal to average vy square is equal to average vz square. That is equation number 4. But we know that Vx, Vy, Vz are the component of velocity of a molecule. Therefore, average V square is equal to Vx square plus Vy square plus average Vz square. Substitute equation 4 or using the equation 4, instead of the average Vy square and average Vz square, we substitute the average Vx square. So 1 times, 2 times, 3 times. Therefore, 3 times Vx square. We require the value of Vx square. Therefore, Vx square is equal to 1/3 average V square. That is the equation number 6. Now, substitute this value of average Vx square in equation 3. Therefore, P is equal to Nm. Instead of the Vx square, 1/3 average V square. That is the equation number 7. Now, what is the N into M? N is the number of molecules per unit volume. That means the N upon V. Now, M is the mass of the one molecule. Now, capital N represents the total number of molecule. M is the mass of one molecule. Therefore, N into M, that is the total mass divided by the volume. That means the N into M represents the density of a gas. Density of a gas, that is denoted as rho. Substituted here, instead of the Nm, we can add the density of a gas rho. Therefore, 1/3 rho average V square. So, it's the equation of the pressure act on a wall of a container due to collision of molecule of a gas. Here is so very easy equation, and that's the important question. To derive the equation of the pressure act on the wall of a container. So keep in mind the equation of the momentum. After that, we have to apply the Newton's second law of motion. We find out the force. Then force by area, that gives the pressure. After that, consider the Vx square as an average value, and also due to the random motion, the average velocity of the particle in all direction or the molecule in all direction are equal using this concept. And last, N into M, that gives the density of a gas. That gives the density of a gas. So this way we can derive the equation of the pressure act on a wall. Just we derive the equation of the pressure. P is equal to, we derive this, P is equal to 1/3 rho average V square. After that, what is the IMS value? Root means square value. Root means square value. And obtain the IMS value of velocity, that means the, what is VIMS? And derive the equation of the VIMS in terms of the pressure. First, what is the IMS value? Definition of the IMS value is, now keep in mind that the IMS must be written in small letter. The square root of mean of square of value. The square root of mean of square of value is known as RMS value. Is known as RMS value. RMS value, that means R stands for the square root, M for mean, and S for square. Root means square value is known as the RMS value of any physical quantity. Now, what is the VRMS? VRMS, that means the square root of mean of square of velocity of the gas molecule is known as the VRMS. Again, the square root of mean of square of velocity of the gas molecule. The square root of mean of square of velocity of a gas molecule is known as VRMS of a gas molecule. Now, again, what is the RMS value? The R, that means the root mean, root square, square root, M for mean, and S for square. Therefore, the root of or the square root of mean of square of value is known as the RMS value. Now, what is the VRMS? The square root of mean of square of velocity of a gas molecule is known as VRMS of a gas molecule. Now we know that pressure of a gas, equation of pressure of a gas, P is equal to 1/3 rho average square. Therefore, average square is equal to 3P upon rho, 3P upon rho. Now we take the square root on both sides. Therefore, square root of average square is equal to 3P upon rho. So here, according to our definition, square root of mean of square value, so that gives the VRMS. VRMS is equal to 3P upon rho. That is important equation. Frequently we are using in numerical. So the RMS value of the velocity in terms of the pressure and density of a gas, VRMS is equal to square root of 3P upon rho. Clear? Again, we repeat the definition of the RMS value. The square root of mean of square of value is known as the RMS value. As we take the square root of mean of square of velocity, that is known as the VRMS. Again, the square root of mean of square of velocity of a gas molecule is known as the VRMS. Now we know that the equation of the pressure of a gas P is equal to 1/3 rho average square. Already here we have the square value of and also mean of square value of velocity. As we take the square root of this, so that becomes the VRMS. Therefore, average square is equal to 3P upon rho. And take the square root of this, so that gives the VRMS value in terms of the pressure and density of a gas. Clear?